Now we're going to learn how to name acids. Well, first we have to identify what acids are. So for our purposes right now, we'll define acids as molecular compounds that release hydrogen ions when dissolved in water. Well, that's very nice, but how do we recognize them? So what we're going to see is that hydrogen is always present in an acid in Chem 1A. So it's going to start with hydrogen, and then there's going to be one or more nonmetals after that. So when we're looking at a compound or formula and trying to decide is it ionic, molecular, or an acid, we're looking at the first element. If the first element is H, it's an acid. If the first element is a metal, it's ionic. If the first element is a nonmetal, it's probably, other than hydrogen, is probably a molecular compound. But we only know how to name compounds that have two elements. So if you have more than two nonmetals, then we need to look elsewhere. So HCl is a molecular compound, and it would be named hydrogen monochloride. It's a gas in its pure form. But when dissolved in water, it forms hydrogen ions and chloride ions. And this AQ in parentheses means dissolved in water. So you can split hairs and say that, if it's HCl gas, that we should name it as a molecular compound, and if it's HCl aqueous, we should name it as an acid. I want you to name anything that starts with H as an acid. Okay? Some characteristics of acids taste sour. So, if you're into sour candy like Sour Patch Kids, that sour biting taste is from an acid on the outside of the candy. Acids can dissolve many metals like zinc and iron and magnesium, but there are other metals that they cannot dissolve. This is a picture of hydrochloric acid dissolving zinc metal. And so it causes the zinc atoms to become zinc ions, and it releases hydrogen gas. And their formulas generally start with H. So there's two different groups of acids, binary acids and oxy acids. So binary acids contain only two elements most of the time. I don't like that word, binary acid. Oxy acids always contain oxygen. I think of them as oxy acids and the other kind. So we'll learn to name both. So for a binary acid, we're going to start the acid's name with hydro, which kind of makes sense because the formula starts with hydrogen, right? So we're going to start it with hydro for hydrogen, and then we're going to look at the element name of the other element that's present. So like HCl, well, we do hydro, and then Cl is chlorine, but here we're going to change the ending to ic, hydrochloric, and then the word acid is always at the end, hydrochloric acid. So, any of those nonmetals, hydrophosphoric acid, hydrosulfuric acid, it's just all the same pattern. So, what would this be? HF. Hydrofluoric acid. And I'll just point out to you, fluorine is UO, not OU, because there's no flour in fluorine. Fluorine is gluten-free. Write the formula for hydrosulfuric acid. Well, what are the two elements in this acid? Hydrogen and sulfur. Hydrogen and sulfur. Is it just one of each? No, it isn't. How do we know? When the acid dissolves in water, it forms ions. What kind of an ion does sulfur form? A 2- ion. And the hydrogen always forms an H+ ion. So how many hydrogens have to be associated with each of these sulfurs? 2. So it's H2S. And then, if you're going to be picky about it, aqueous. Any questions? There aren't that many binary acids. Oxy acids. So oxy acids contain oxyanions. If you look at the formula of an oxy acid and you stick your finger over the H, I'll probably accidentally do something that we're going to do, but oh well. So there's an oxy acid. It starts with an H. That means it's an acid. It's got oxygen in it, so it's an oxy acid. So if I cover up the H, what do I have left? You have NO3, which is a polyatomic ion that was on the list of things you're supposed to memorize, right? So the name of this acid is going to be based on the name of the oxyanion. So this oxyanion's name is nitrate. And so if it ends with 8, we're going to change that 8 part to ic, and we're going to get nitric acid. If it ends in ite, then we'll change the ending to us. So this is another one of those places where we have 8 and ite, ic and us, and we have to keep them together. We have to have them paired up. Oh, I thought I had this on the slide. I don't. So there's a couple of things that you can do. One I've heard is the white mouse ate icky cheese. And you're like, how's that going to help? I'll show you in just a minute here. So there's ick and ate. And here's ite and us. Okay? I don't remember where I got this one. Rick ate him before he could bite us. It's silly, right? Rick ate him before he could bite us. So there's an extra O in there. Us and ite, ick and ate. Okay, any questions? They're easy to confuse, but you learn one of these sentences and you can figure it out real fast. So let's practice. Here we have, let's name the acid HNO2. So if we cover up the H, what do we have? We have nitrite, we have NO2. So that's the nitrite ion. So what do we change ite to? Us. So this is nitrous acid. Nitric acid has 3 oxygens because it's from nitrate. Okay. Write the formula for perchloric acid. So we're going to do the process backwards now. This acid name ends in ic, so we're going to change that to 8. So this comes from the perchlorate ion. So we need the formula for perchlorate. Anybody? ClO4 and a -1 charge. All of these oxyanions, they've got the other element name in the middle here, and so, you should be able to guess ClO with some number and some charge. It's better than nothing. So that's perchlorate. And then it's also going to have hydrogen ions, because that's what come off when it dissolves in water. So this is going to be HCl O4 aqueous. Any questions? This just needs some practice. Okay, so those were the oxy acids. So writing formulas for acids, this is kind of, I shouldn't even say this, but if the name ends in acid, it's an acid, right? And so we know first element is H. We're going to write the formula as if it was ionic, even though it isn't. It's molecular. If the first part of the name is hydro, you've just got hydrogen and something else. It's not an oxy acid. Without the hydro, that means you do have an oxy acid. And for the oxy acid, ic comes from the ion with the ate ending. Us comes from the ion with the ite ending. We already did an example of one of those. So write formulas for the following acids. Hydrocyanic acid. Is this an oxy acid? No, because of the hydro prefix, right? So it's H and something else. It's CN, it's cyanide. This is the one that ticks me off because that's not a binary acid. It's got 3, but it's not an oxy acid. So it's cyanide. So HCN is hydrocyanic acid. How about phosphoric acid? Boxy acid or binary or oxy? It's a boxy acid, it doesn't really have a shape. It's an oxy acid. So we change ic to 8. So this comes from phosphate. What's the formula for phosphate? PO4, 3 negative. And we're putting that together with hydrogens. So what's the formula? H3PO4. Because you can just look at this and picture, this is a -3 charge. I'm going to need 3 of these guys to balance that charge. That's all we're doing. How about number 3, hypochlorous acid? Well, is it an oxy acid? Yes. It's like it's trying to disguise itself though, right? Because it's got the HY, but it's not hydro, it's hypo. This is an oxy acid. And us goes with ite or ate? Ite. So this is from the hypochlorite ion, which has what formula? ClO and a -1 charge. We need the charge because the charge is going to tell us how many hydrogens it's going to need. So for this one, we're just going to have HClO. Any questions?